Okay, so in question 12, this question is a follow-up question to question 11, where we determined whether, no matter whether what the charges here are, the net force, the sign of the charges here, the net force in this charge is 0. And you can check out that video in question 11. So for this question, we're stating that the lower half of the ring is replaced with a small ball, with a total charge equal to that on the lower charge, equal to that on the lower half of the ring is shown. So there was a ring here that had a total charge Q. So now the semicircle has a Q over 2, and then the lower half is replaced with the ball of total charge Q over 2 also. So we still have the semicircle plus the ball, so there's a total charge of Q. The ball is placed at distance R0 away from the particle Q. After the change, the net force exerted on the particle is upward, downward is 0. So let's work through this question. Okay, so since both the semicircle and the ball charge are the same sign total charge, but the semicircle we can sort of think of breaking up into smaller components, smaller sort of subset of charges, each of which exerts a force on the Q in the center. There will be a cancellation of x components. So the net force exerted by just the semicircle will, on the charge Q will have a smaller magnitude than that on by the Q over 2. Now in this particular case, it's not going to be possible to answer this question without knowing the sign of the charges. So I believe D is correct. So I can maybe, just for an additional sort of review, we can do a couple of different choices, so we can see why the answer is D. So there's lots of different options here, because I've got technically three different charges, and I'm not sure if, again, if the Q in the ball has to be the same sign charge as the Q on the ring, but let's say if all charges are positive, positively charged, and so maybe I'll make the ring sort of a wineish color and the ball a red color, and I'll draw forces that would be exerted on the Q. So if all the charges were positive, then the free body diagram would look like that if the Q over 2 on the bottom of the ball would exert an upward force that would be larger in magnitude than the downward repulsive force by the ring, again thinking that here the total charge is the same, but if we thought about exerting, sort of doing a vector sum of all the force exerted by the charge in the ring, the cancellation of the x components and only the summing of the y would lead to a smaller force. So I'll draw a force of this. So in this particular case, the F net would be upward, in the upward direction. And again, if I made all charges negative, the same thing would happen, because it again would be just repulsive. So I can add it into here to also negatively charged. And both of those, in a sense, would give me the case again: repulsive force by the bottom, repulsive force by the one on the top if the Q is a small Q, if all of the charges are negative. But if we think about if the ring and ball are positive and Q is negative, okay, so I've made the ball and the ring the same, but I've made Q negative. Well, in that particular case, if the Q is negative and both of these are positive, there will be attractive forces. In this particular case, there will be a large attractive force downward. I don't want to make it a circle. If the ball is plus and the Q is negative, large downward here, there will be a smaller upward attractive force to the ring, and the net force will be downward. You can definitely rule out, there's no way that the force could be zero. You know, you rule out choice C, because the force, but no matter what the sign of the charge here of the Q over 2, it's not, it's always going to be bigger than that of the ring. What our choice is going to do, yeah, if you made the ring and the ball negative and the small q positive, you would also get the same answer, I believe. Yes, so if the ring and the ball are negative and q is positive, again you'll still get a net attraction downward to the ball and a net attraction upward to the ring if you just swap the signs. Okay, so then if I sort of maybe do one more where I don't make the ring and the ball the same. So if the ring is positive, the ball is negative, and say Q is positive. And what will we have in this particular case? So if the ring is positive and the Q is positive, then there will be a repulsive force, and there will be a repulsive force by the ring, and if the ball is negative and the Q is positive, there will be a larger attractive force, and a larger one. So in this particular case, the net force will be negative. Sorry, the net force will be downward. So I guess we've shown cases where the F net can be downward, the F net could be upward. It can't be zero, but it's not possible to distinguish between upward and downward if you don't know the signs of the charges. So D is the correct answer.